Hey there. Today's another chapter, a new chapter in our lives. Very exciting stuff. So, chapter 7 is about conic sections. Let's see. Just in case you're curious, if you don't really care what they are or where they're used in the future or in real life, then you can fast forward if you want. But let's see. Conic sections. They are, all ways in which a plane, and no, plane in real life we think of a plane as an airplane, but in math a plane is like a infinitely flat object that goes on forever, kind of like a piece of paper, so imagine there's a piece of paper, but it goes on forever. It's not like it ends, it's just infinitely flat, and then it goes up and down and left and right forever, in which a plane can intersect a cone. So that sounds kind of weird, but in math, a cone isn't like, it is like an ice cream cone, but a cone it kind of has two parts to it. It's more like an hourglass, I guess, is what I would say. It looks like this, sort of. And actually, a cone, it goes up forever like this, and it goes down forever like this. So it's a three-dimensional object that looks like an hourglass, yeah, but it goes upward forever and downward forever. But let's see, just for, curiosity's sake, let's see, what are all the ways that a plane can intersect a cone? There are actually 4 ways, and we'll study all 4 of them. Well, we've actually studied a couple of them before, but so let's see, I'm going to draw 4 different pictures so we can kind of see the 4 different ways. Here's 2 cones, okay. Let's see, here are 3 cones. And the 4th cone will be down here. Okay. Let's see, so one way in which a plane, which is like a piece of paper, imagine, can intersect a cone would be, what if it intersects it just kind of perfectly horizontally, I guess. Then what you want to know is what shape it makes their intersection. If you kind of think about it, it looks like it makes a circle. Well, the way I drew it, it looks more like a ellipse or like a oval, but if you were to be looking from overhead, it would actually be a circle. So like I said, what we're looking for is the part where they intersect. So that would be this circle here in the middle. But those we've already studied. I think we've studied them to the point where we get everything about them. We don't need to study anymore. So that's why there are only 4 sections in this chapter that we care about. There are only 3 sections in this chapter, and they go for the remaining ways that a plane can intersect a cone. So the second way that a plane can intersect a cone is, what if I did almost the same thing as with how we got the circle, but I tilted it a little bit. So here's my plane or my piece of paper type thing, but it's intersecting the cone kind of at a skewed angle, sort of. I think it would make a similar shape, it's just it would be sort of more of an oval or an ellipse. Oval, or yeah, in the math world we call it an ellipse. And I think in physics they call it ellipse too. So the shape that one would make would be kind of an oval shape or an ellipse shape. And let's see, how else could it intersect? Well, I guess another way it could intersect is, what if it just barely clips the edge of the cone like this? Something like, like that, I guess, sort of. That one's kind of hard to picture, but if it did intersect it like that, then I think it would make some sort of a parabola shape. Something like that. So that's the third conic section. So we will study those again. And I know parabolas we've already studied, but we're going to study them in this kind of new context. We're going to see them in the geometric context. That'll be the next section. The geometric, context. So that'll be section 7.2, the next section. Right now, this section we're actually studying the ellipse, which is the second one we drew. The third one, though, this will be for section 7.3, the last section we care about in this chapter. That'll be a hyperbola, which you would get if you took the plane and you tried to intersect it with the cone at a perfect kind of vertical angle. Something like that. Then it's like, it would intersect the cone at the top part in a kind of a parabola looking shape like that, but it would also intersect the bottom of the cone in a similar shape. So that's called a hyperbola. And we'll see those guys again. They look like basically 2 parabolas that are facing away from each other. So that's where this all comes from, and And this seems kind of useless, just thinking, okay, how can a plane intersect a cone? What the hell? Who cares? But each of these 4 shapes, they are important in different places, like physics or optics. Like the shape of a lens that goes in a telescope, or what else? Telescope or a microscope, stuff like that. It's always going to be in one of these shapes. And like in physics or astrophysics or whatever, the way that an object orbits another object, like a moon orbits a planet or something like that, it's always in one of these shapes. It's either a circle or an ellipse. Like I think we go around the sun, the Earth goes around the sun in an ellipse shape, or parabola or hyperbola. Different satellites and things like that might approach Earth or other places in one of those shapes. So kind of interesting. It's probably, most people are never going to see these again, but if you happen to study physics or you're going to create microscopes someday, then yeah, you might see these guys again. But this section, like we said, we're going to focus on the ellipse, the first one we drew, the second one we drew, which is pretty much just an oval shape. So let's see, I just kind of curious what they say here. The U.S. Capitol building is beautiful both inside and out, but did you know that part of its architecture includes an elliptical ceiling and sanctuary hall? John Quincy Adams, while a member of the House of Representatives, discovered that he could use the reflective properties of this room, which we will study in this section, to eavesdrop on the conversations of other House members. Now that's interesting. That's a smart man, huh? How do you know that? Yeah, so I think that's pretty much where these are useful, is these shapes kind of have certain special reflective properties. Like that's why you would want to use them in a lens, either a telescope or a microscope or something like that. But let's see, we'll get more down into the math now. The first objective is to kind of look at what does the equation or the function look like when you're talking about an ellipse. So okay, the equation of an ellipse is simplest if the center of the ellipse is at the origin, and the foci, they call them, are on the x-axis or the y-axis. So if you're looking at an ellipse, here they have pictures of 2 of them, but like here's an ellipse. The foci are these points here and here, or if it's more elongated vertically, then your foci will be here and here. So it kind of looks like a pig's nose is what it looks like to me, but oh well. And we'll see how do you figure out how to find the foci and all that stuff. But okay, sorry, it's hard to see on this. I think this picture's been kind of screwed up, but the equation of an ellipse looks like x squared over a squared plus y squared over b squared equals 1. And that's if it's kind of this horizontal ellipse, I'll call it. It's an ellipse. Because to me that means it's kind of elongated horizontally. And the other equation, it looks similar, but it's going to be x squared over b squared plus y squared over a squared equals 1. So it's like the numbers below x and y kind of switched places. And that'll be the equation for a vertical ellipse, which just means it's taller than it is wide, Which way's the circle been stretched to make an ellipse? And then now we'll talk a little bit more about that the foci. Foci is the plural of focus. You're looking for there are 2 focuses. But let's see, c is the value we need to find to figure out the focus. C is the distance from the center of the ellipse to the foci. So if you kind of look at that little pig nose that I drew, the center of the ellipse would be, like, say, here. So the value of c would be the distance from that center to that foci. And I think they've kind of outlined that in the picture that they drew too. But that kind of, the red drawing that we've done is kind of simpler looking. So okay, then what else? And then if you want to find it, what is the horizontal ellipse means a is bigger than b. Then the foci are located at c, 0 and negative c, 0. In which case, c squared equals a squared minus b squared. If it's a vertical ellipse, which means, well, that pretty much just means it's taller than it is wide. The foci are located at 0, c, 0, negative c, in which case c squared equals b squared minus a squared. Oh, that's a lot to take in. You definitely need to practice on these and see a lot of examples to really get it. So here's just a simple example of the equation of an ellipse. So it looks like the value of a is the number below x, but notice, the equation that we're given here, the number below x is a squared. So actually it's a squared equals 16. which means that the value of a should be the square root of 16, or 4. So when you try to find a and b in these problems, it's always the square root of the number below x and the square root of the number below y. So I'll do that to find b as well. B squared is 4. That means b is the square root of 4, or 2. Alright, so then now I decide, based on those values, is this going to be a horizontal or vertical ellipse? Well, then I just look at a versus b. Which one's bigger? Because a is larger than b, and a was a number below x, 16, and then b was a number below y, 4. That means it's going to be a horizontal ellipse. This is a horizontal ellipse. That just means it's going to be wide, you know, as opposed to tall. Okay. So I think actually we can go ahead and graph the ellipse first, and then we can find the foci, which is, like I said, the plural of focus. So all we do is I'm going to, from the origin, I guess, to graph, kind of like a circle. But, you know, a circle, remember, what do we do to graph a circle? We just say, okay, from the center of the circle, we're going to extend out left, right, up, down, whatever the radius is, and then we'll connect the dots. This is going to be similar, except the only difference is the vertical and the horizontal distances will be different. So from the center, which in this case is the origin, because this objective is only talking about ones that are centered at the origin, I'm going to extend a units left and right, because that's what the value of a means. The number below x tells you how far left and right from center of the ellipse goes. And then I'm going to extend b units up and down, because that's what the value below y represents. It's how far up and down you're going to go from the center. So let's see, a was, what was a? A was 4, and b was 2. So from the center, I'm going to go left 4 and right 4, and up 2 and down 2. That's pretty much it. So that should be what the ellipse looks like. And then I'll just try to round it out, make it look more like an oval. Something like that-ish. Okay, so that's the graph of the ellipse. It looks good. But then they want us to find the foci. Foci. Which, like I said, is the plural of focus. Because there are two of these focuses. Plural of focus. Okay, so to find them, we're going to say c squared is a squared minus b squared. That was kind of the little formula or the little equation that we were given. Let's see here. Up here, c squared equals a squared minus b squared. And I'll fill in what I know. So, okay, c we don't know. That's what we're trying to find. A was 4 and b was 2. So c squared is 16 minus 4, or 12. But if I want to solve for c, I'll have to square root both sides. Okay, and that simplifies to 2 root 3. So as I described above, the foci, the plural, they're going to be at c comma 0 and negative c comma 0. That's what was described above. And c we said was 2 root 3, so it'll be 2 root 3 comma 0, negative 2 root 3 comma 0. So that should be probably somewhere around, let's see, here or in here. There are the foci. And I think, you know, foci, we don't really know why they're important. They definitely aren't necessary to graph the ellipse. We definitely graph the ellipse without even knowing the foci. But when you do the applications in physics or, yeah, optics or whatever it is, I think the foci are important. They represent things in real life. Like, I think there was one example I saw where it was like a satellite dish. You know, if you have a satellite dish facing upward, you know, something, whatever. Oh, God, that's terrible. Then where should the, I don't know, what do you call it? This little thing? You know, of a satellite dish? The receiver? Is that what it's called? Yeah, where should the receiver be? And it ends up being that the receiver, the best place for it to be, to receive all the right signals is right where the focus would be if you think about the ellipse. So, it's kind of interesting. There are real life applications. Right now it seems like, what the hell is a foci? Why do we care? But yeah, it's like in applications you actually care. Okay. So this next one, it says, okay, graph and locate the foci. So it looks similar, but then I look at this equation, and this looks nothing like the two over here. You know, if it's a horizontal ellipse, it looks like this. Okay, I don't really see denominators underneath x and y. If it's a vertical one, it's the same thing. It's just a and b are switched. So that's kind of the weird thing. There are no denominators. So there should be numbers beneath x and y in order for me to figure out what a and b are. There must, yeah, be denominators for x and y to determine the values of a and b. A and b. But another difference between the equation that we have here and these kind of general equations that they've given us is, notice what's on the other side of the equation from x and y. There's a 1, right? It's no matter what. So I think that's a big problem, and that'll kind of give us a hint as to what to do to fix this problem. So this should be a 1 instead of a 144. Because if it's not a 1, it definitely doesn't look like the equation of an ellipse that we're supposed to see. But you know what? We can make it a 1. I'm going to divide the entire equation by 144. And I think that'll produce denominators on the left, which is what we wanted, and it'll produce a 1 on the right, which is what we wanted. Divide the equation by 144, and I think that'll do it. So I got 16x squared plus 9y squared is 144. Okay, then what? We're going to divide the whole equation by 144, so that means each individual term is divided by 144. Alright, there we are. And you know what? I think the first guy reduces. I think 16 goes into 44 9 times. Is that right? That would be x squared over 9 plus, and then similarly 9 goes into 144 16 times. So that becomes y squared over 16 equals, and then of course 144 divided by 144 is 1. So this is really the equation. That looks a lot more like the one we saw before. So let's see, the value of a, the number below x, well, a squared is the number below x. That means a is the square root of that, or 3. So we have a, and then b, similarly, b squared is the square root of the number, sorry, b squared is the number below y. That means b is the square root of that guy, or 4. So we got the values of a and b, and now I can kind of determine if this is going to be a horizontal or vertical ellipse, since a, which is 3, is smaller than b, which is 4. That means it's going to be a vertical ellipse, which just means it's taller than it is wide. And that means that too, the foci, when we find the foci, they won't be at c comma 0 and negative c comma 0, they'll be at 0 comma c and 0 comma negative c. I guess it's kind of like, okay, if it's a horizontal a horizontal ellipse, then the foci the c values will be in the x values, like horizontal kind of makes sense. But if it's a vertical parabola, then the values of c will be on the y-axis, the y values. That's kind of how I remember it. But let's do that in a second. Now we're going to just graph this ellipse. So it says we're supposed to extend left and right a units, and a is 3. So from the origin, or from the center, I'm going to go left 3 and right 3. And then b represents the vertical height of this thing. So I'm going to go up b units, which is 4, and down b units, which is 4. And then just kind of round out that shape, try to make it as nice as possible. So this one's obviously closer to a circle than the last one, and that's because the values of a and b were a lot closer than they were before. So there's the graph, but now I can find c. C squared is, it's going to be either a squared minus b squared or b squared minus a squared, depending on which one's bigger. It looks like b is bigger, so it's b squared minus a squared. That's how we described it over here. It said if it's a horizontal ellipse, you find it using this equation. That's what we did in the first problem. But now since this is a vertical ellipse, we're using this equation. So now b comes first and then a. So c squared is, b was 4. Oh, sorry, a was 3. So it's 16 minus 9, 7. And we'll square root both sides to get the square root of 7, which doesn't reduce, so that's it. Okay, but the foci, those are points, so it should be 0 comma that value and 0 comma negative that value. So the foci, they didn't ask us to plot them, but they're somewhere, I think, let's see, the square root of 7 is somewhere between 2 and 3, so it's like, here, let's say. And then same thing here. So there they are. I guess that's the thing is, when you got a ellipse centered at the origin, your foci are either going to be on the x-axis or the y-axis. it depends whether this ellipse is taller than it is wide or wider than it is tall. Like in the first one, if it's a wide ellipse, then the foci will be on the x-axis. They'll always be on the wider portion. But in the second problem, it was taller than it is wide, so it'll be on the y-axis. These are kind of weird, yeah, I gotta admit. Alright, now we're kind of going to go backwards. They're going to tell us some information about the graph of the ellipse, and we have to find the equation. That's going to be maybe a little more difficult, maybe not. So it says, find the standard form of the equation of the ellipse with foci. Okay, so that means this is negative c comma 0 and c comma 0. And then vertices, negative 3, 0. So this must be a, negative a, and a, 0. Because remember, b, the values of b are always the points here and here. And those points look like 0, comma b and 0, comma negative b. They're the b values in the y coordinate place. But here, since they're giving us points that have a non-zero value in the x coordinate place, those must be the a values. It looks like we know c is 2 and a is 3. So we kind of know a lot about this, this equation. But the basic form of the equation should look like this. X squared over a squared plus, y squared over b squared equals 1. Oops, let me see. Try to erase that mess up there. There we go. And we know a, so we can fill that in. A is 3. So it should be x squared over 3 squared plus y squared over, okay, we just have to figure out b, and then I think we're done. So whatever we get for b, find b. Okay, well we know the equation that kind of relates c and a and b. It must be, let's see, c squared equals a squared minus b squared. And I know that's the one. It's not b squared minus a squared, it's this one, because this is going to be a horizontal ellipse. And I know that because they gave us the foci have the c values as the x values. That only happens in a horizontal ellipse. As we saw in the previous example, a vertical ellipse would be the one that would have the c values in the y coordinate. And I know a horizontal ellipse has this equation that relates the c value in the a and the b. So I'll fill in what I know, and then I think I should be able to solve for b. C was 2 and a was 3. Okay, I'll fill those in and then solve for b. 2 squared equals 3 squared minus b squared. So this is 4 equals 9 minus b squared. I'll move the 9 over. That'll make negative 5 equals negative b squared. You know, I'll get rid of that negative by, I guess, dividing by negative 1. That way 5 is equal to b squared. And then to get rid of the square, I'll square root both sides. So b must be the square root of 5. I'll put that in there, and then I'm all done with this problem. Square root of 5. Yeah, and you know, you can probably simplify that. I'd imagine that they'd probably write that as x squared over, and then instead of 3 squared, they'll just write 9. They'll actually square it out. And then plus y squared over, and here you're squaring a square root. They'll cancel each other just to leave the 5 that was there. That's probably more the way you'd see it. Of course, what we boxed here is fine. That's the right answer. It's just kind of, I guess, not simplified all the way. This is probably more like what you'd see. It looks a lot simpler and nicer, I guess. Okay, let's try that again now. This one, though, they're giving us foci. Notice the foci are 0, comma, negative c, and 0, comma, c. Foci, they only have their c values in the y coordinate if it's a vertical ellipse. So we know it's vertical. Okay, that's good. And this and the other two vertices are... And vertices, if you're wondering what the hell is a vertice, vertices are kind of like, I think of as the edge points. So if you were to graph your ellipse, it looks like this maybe. The vertices are like how high, how low, how far left, how far right. There are 4 vertices on any ellipse. So they're giving us 2 of them. 0, negative 7, so that'd be like this guy here. And then 0, 7, that'd be like this guy up here. But it looks like since they're giving us kind of the upper and the lower points, or the upper and the lower vertices, those must stand for the b values, because a is the x-coordinate of the vertices and b is the y-coordinate. So this must be 0, comma b, and this is 0, comma negative b. So not unlike in the last one where we knew A and C, now it looks like we know B is 7 and C is 4. So it looks like, yeah, C is 4 and B is 7. So we know those. We'll have to find A. And then our job will just be substitute that into that kind of general equation, x squared over a squared plus y squared over b squared. But let's see, since this is the vertical, vertical ellipse, that means the equation we're trying to solve for A is c squared equals b squared minus a squared. So I'll fill in what we know. Let's see, we know C and we know B, we don't know A. Let's find that guy. So let's see here, yeah. C was 4, so we'll replace that guy. And let's see, B was 7. So let's see, that's 16, 49, a squared. Okay, let me move that 49 over here. Let's see. That's 49. Okay, then what do we get? Negative 33? Is that right? Yeah, okay. Alright, and then the last step, or well, second to the last would be get rid of the negative by, I guess, dividing or multiplying by -1. That'll give me 33 equals a squared with no negatives. But the last step would be square root both sides. A must be the square root of 33. So now that we have the values of A, B, and C, we should be able to finish this problem. The general equation of an ellipse looks like x squared over a squared plus y squared over b squared equals 1, and then I'll just fill those in, the a and the b. Remember that in any kind of function or equation that represents a graph, x and y should just stay x and y. You shouldn't replace them. They should always be there. I mean, if you just want the equation. So let's see, a was the square root of 33. We'll put that here. And b was 7. Alright, and then I think, like I said before, I think they'd simplify that. This is x squared over the square root on the 33, and the square would cancel just to leave 33. This is y squared over 49, because I'm just squaring the 7. And that's all they really want. So really, in these problems, when they want the equation of the ellipse, your job is just to find a and b and then fill them in. That's all you really need to do, and then, yeah, you should be good. So C is not really necessary. It's just helpful to help us find A or B, whichever one was missing. All right, so this objective 3 now is talking about, well, what if you had an ellipse that was not centered at the origin? So that definitely complicates things, because so far all we've seen are ones that are centered at the origin. So okay. So the only difference is, as you'll kind of see in this example, this first one, there are now numbers that are in the numerator with x and y. And those will represent the center. So in these ones, the center is similar to the circles. So if you remember, when you have a circle, if you want to find the center, it's like h comma k, and you have to change both signs. So h is the value that's inside the parentheses with x, so it'd be the 1, but I changed the sign to a negative. And k is the number that's inside the parentheses with y, but it looks like a -2. I'm going to change its sign to a positive. Change both signs. Okay. So h and k are -1 and 2 respectively. That means that's going to be the center of the ellipse. So this is where it's going to be centered. It's going to be not centered at the origin. It'll be centered there. But otherwise, I'm going to find the same things, the values of a and b. So a is going to be where? Uh-oh. A is the square root of the value below x, so 9. Square root of 9, which is 3. B is the square root of the value below y, which is 2. So this is where it gets a little more complicated. So now, instead of extending left and right 3 units from the origin, I have to extend left and right 3 units from that center. So from where that center is, I'm going to go left 3, 1, 2, 3, there's a point. And then right 3, 1, 2, 3, there's another point. And then the b value, instead of going up and down 2 units from the origin, I'm going to go up and down 2 units from that center. So above that center, 2 units, and below it, 2 units. That's where they are. And then I'll just kind of connect the dots to look like a nice little oval. It looks about right. And this one, they want to know where the foci are. So let me make it more clear. Let me see. Where am I going to put this? Foci. Foci should be, let's see. I guess it depends. Yeah, it's kind of complicated, but it depends if it's a horizontal or vertical ellipse. if it's a horizontal ellipse, okay, then the foci are the points h plus c comma k and h minus c comma k. If it's a vertical ellipse, then it looks like h comma k plus c, and the other point is h comma k minus c. And so they look like that because you're taking the center, and if it's a horizontal ellipse, then the foci are to the left and to the right of it, which means you're going, when you go left of a point, that means you're taking something away from the x value. If you're going right, to the right direction from a point, you're going to add something to the x value. In a vertical ellipse, the foci are above and below it. If you're trying to take a point and go a few values above, you're just adding something to the y value. And if you want to go below a point, you're subtracting from the y value. That's kind of the idea, and what you're adding and subtracting is c. So, okay, let's determine first if this is going to be a horizontal or vertical ellipse. Well, it depends with which one's bigger. A is 3 in this case, B is 2. That means A is bigger than B, and we know that means it's a horizontal ellipse. Horizontal ellipse. Okay, so we can find the foci, but we first need to determine what c is. C squared, same equation that we saw from the previous objectives. C squared should be a squared plus b squared. C we don't know, but a is 3 and b is 2. So this should tell me what c is. Let's see, I'm filling those in. Yeah, a is 3, b is 2. So come on, c squared is 9 minus 4. So c squared is 5, which means if I square root both sides, c is the square root of 5. Alright, and then like we said, the foci, if it's a horizontal ellipse like what we have, the foci should be 2 points. One of them is h plus c comma k. The other one's h minus c comma k. Alright, because that's what we said over here, yeah. This is a horizontal ellipse, which is because a is greater than b. If it was a vertical ellipse, that would mean a is less than b. Okay, h. I already forgot what h was. H was -1. Okay, -1 plus, and then c we just found, square root of 5, comma, okay, I forgot what k was. Don't make fun of me. 2, that's right, 2. So there's 1 point. The other point is similar, except I'm just subtracting c. So it'll be -1 minus the square root of 5, comma 2. Let's see, I'm just curious. What is -1 plus the square root of 5? So that point, just in case you're kind of curious what that looks like, this is about 1.24, comma 2, something like that. So where would that guy be? 1.24, comma 2. So it's like around here. And I think the other point would be similarly on this side. So foci, yeah, they should always, if it's a horizontal ellipse, they should always be left and right of the center. And then if it's a vertical ellipse, they should always be above and below. So okay, anyway, I guess I should highlight the answer, huh? Well, the foci. There they are. They're the two guys. And I guess the graph is also important. All right, let's try this other one. Like I said, this section's very difficult. It's a lot going on. There's so many letters that stand for things and the graphs and everything. It definitely pays to do a lot of examples and practice a lot. So let's see. H comma k comes from the numbers that are inside the parentheses with x and y. Center should be h comma k. H comes from the number that's inside with x, so 4, and I changed the sign, so it's not a -4, it's a +4. And then k comes from the number that's inside the parentheses with y, but I'm changing the sign to a negative now. So we know the center. I can plot that if I want now, just to get ahead of myself. 4, comma -2. So there's the center. Okay, and then if I find the values of a and b, a should be the square root of the number below x, so 3. And b should be the square root of the number below y, so 5. Then I should extend left and right 3 units from the center, and up and down 5 units from the center. So okay, from that center I'm going to go 3 left, there we go, 3, and then 3 right, but 5 up, 1, 2, 3, 4, 5, and 5 down, 1, 2, 3, 4, 5. There we go. So just either looking at the graph or looking at the values of a and b, I can tell this is a vertical ellipse because it's more stretched vertically than it is horizontally. So this is a vertical ellipse. So that means, first of all, that I'm going to be, to find C, we're going to be using a slightly different formula. C squared equals B squared minus A squared. It's kind of like whichever one's bigger, B or A or B, is going to be the one that comes first in this little formula. So that's one thing. And then also, because it's a vertical ellipse, that means once I find C, the foci are going to be at h comma k plus C, whatever that is. And then also the other one is going to be h comma k minus C, whatever the hell that is. But first we got to find C. Okay, let's see. I'll fill things in. C squared is B squared minus A squared. But what was our B? B was 5 and A was 3. So C squared is, that's 25 minus 9, or 16. If I square root both sides, I get 4. And if you ever think, at these ones, well, I thought when you square root both sides, you have to put plus or minus. Yeah, but these values, A, B, and C, and H and Q, just A, B, and C should always be positive. So I guess in other contexts, yeah, we want to put a plus or a minus, but, yeah. So there's C. I'll fill that in. And H comma K, God, I already forgot what that was. 4 and negative 2. I'll fill those guys in as well. 4 is the X value. Negative 2 is the Y value, and then plus or minus C. In the last problem, I couldn't simplify those, but this time I can. I can say this, because the Y values are actually like terms. Negative 2 and 4 makes 2. And the other guys, 4, which is 4 comma negative 2 minus 4 is negative 6. So there's your foci. And if you're ever worried, that was a lot of steps just to find the foci. Because I had to use the formula to find C and then plug those in. Plot those points and make sure they kind of look like what they're supposed to look like. 4 comma 2 would be, let's see, around here. And that looks about right for a foci. It should be above and below the center if it's a vertical ellipse, so that's good. And then 4 comma negative 6, which is here. Yep, that looks about right. Not that they asked us to plot the foci, but it just kind of helps you check your answer if you plot them. Okay. I think this is the last objective, thank God. This is definitely my least favorite chapter, if I'm being honest with you. But this part's kind of interesting, I think. I mean, I'm weird, but whatever. This shows one way that you might use ellipses in real life. So a semi-elliptical archway, that just means it looks like, a half ellipse, like that, it looks something like that. I guess there's a road going through the semi-elliptical archway. I don't know, maybe it's made of bricks. Okay, why am I getting off on a tangent here? Whatever. It's bricks, okay? Don't worry about it. And then there's like is it a truck? I guess a truck's driving through it. So there's a road going through, off into the distance. There it is. Dang. Look at that art. Freaking amazing. If I do say so myself. All right, You're driving a truck through there, or you're trying to drive a truck through there. Damn, is this an art class? Or a math class, am I right? Damn. Okay. That's enough. A semi-elliptical archway over a one-way road. Oh, I put a line down the middle. Whatever. Has a height of 10 feet and a width of 40 feet. Okay, so that means, from here to here is 10 feet. The height. I mean, not the height of the wall, but the height of the archway. So from here down. And then what else? It's got a width of 40 feet. Okay, I definitely didn't draw this to scale, but whatever. This is 40 feet from here to here. Your truck has a width of 12 feet. Okay. 12 feet and a height of 9 feet. Okay, 9 feet. Interesting. Will your truck clear the opening of the archway? Interesting. So I think, what you want to do really is picture this on the XY coordinate system. And actually, since you're creating this XY coordinate system, you're free if you want to put this ellipse right on the, so it's centered at the origin. So if you want, you can make it go, I guess, there's no part of this archway that's below the x-axis, but whatever. It's an ellipse. Okay. So it's going to be x squared over a squared plus y squared over b squared equals 1. That's kind of the basic function. I just got to figure out what a and b are. Well, if you look at the graph, a represents the distance from the center to the outside. B represents the vertical distance. So So the way they described it, it sounded like, okay, the archway was 10 feet tall, which means B is 10. But they said that this archway was 40 feet wide. But 40 actually represents the entire distance across, like from here to here. You know, this guy, the whole thing is 40. But the value of A isn't the whole way across, it's from the center to the outside. So A should actually be half of that, or 20. Half. But the vertical distance for the archway, or the height of the archway, was only from the center to the top. Because this is, like they said, it's a semi-elliptical archway. It's not an entire archway, it's only the top half of an ellipse. So we know the values of A and B. I'm going to fill those in. So we kind of have an equation that represents this archway. X squared over that A value squared plus Y squared over that B value squared equals 1. Let's see here. A was 20 and Y was 10. Or sorry, B was 10. All right, we'll fill those in. Then maybe I could simplify. That's X squared over 400 plus Y squared over 100. This is, I guess, the equation of the ellipse that represents the archway. The archway. Yeah. So what we're gonna do now is we're gonna see, okay, what if I have a truck that's a certain height, or I guess a certain width? I don't know, how wide or how tall can it be and still fit through? So it says your truck has a width of 12 feet and a height of 9 feet. Will your truck clear the opening? Okay. Let's see. Well, if the width is 12 feet, let me see. The truck has a width of 12 feet. So that means that it's going to be something like this. This will be the width of your truck. It's going to try to go through, like this. I don't know if it hits the top or not. But that means, what is the X value? The X value won't be 12, because 12 is the distance all the way from the negative side to the positive side. The X value will actually be half of that. Half of 12, or 6. Kind of similar to where we got the value of A. A was half of the horizontal distance across the archway. So what we're going to do is we're going to plug in X equals 6 into the equation of the archway and solve for Y, to find out how tall the archway is at that place. To find how tall the archway is at 6 feet from center. We'll figure out, okay, well, if that's the height of the archway, would my truck fit depending on how tall my truck is? So, okay, what was the equation that we came up with? It was X squared over 400 plus Y squared over 100 equals 1. But we said that we're going to plug in a 6 for X, and then we should be able to solve for Y. Okay. X equals 6. Here we go. 6. Let's see, then what is that? That's 36, because 6 squared is 36, over 400 plus Y squared over 100 equals 1. And then I want to solve that for Y. Let's see, what's 36 divided by 400? Is that nice? Well, at least it reduces, I think, right? This guy, 36 goes into 400. Well, 4 goes into both. 4 goes into 36 9 times. Wait, is that right? Yeah. 4 goes into 400 100 times. So I can write this as 9 over 100 plus Y squared over 100 equals 1. I think there's a few ways to solve this, but the way I would do it, though, is I would clear denominators. I'm going to multiply the whole thing by 100, just because I think this problem will be a lot easier if there are no denominators. I mean, the hundreds will cancel from the fractions, leaving just 9 plus Y squared, but that 1 on the other side is multiplied by 100 to leave 100. And now it's going to be a lot easier to solve for Y. I'm going to move the 9 over. Minus 9, so Y squared equals 91. Okay, whatever the hell that is. So Y must be the square root of 91, which is about, let's see, square root of 91, oops, is 9.5, okay. Feet. Alright, what does that mean in the context of this problem? That means that 6 feet from the center, the archway is 9.5 feet tall. Okay, so 6 feet from center, the archway is 9.5 feet tall. Is that going to allow my truck to fit? How tall did they say the truck was? The height of the truck is 9 feet, so it'll barely fit. The height of... You better definitely make sure you drive right down the center. Don't go any further to the left or to the right. Truck is 9 feet, so it will fit. Barely. Whew, that was good. So that was complicated, but we have another one here just to really drive it home. So it says, will a truck that is 8 feet wide carrying a load that is 7 feet above the ground clear the semi-elliptical arch on a one-way road that passes under a bridge that has a height of 10 feet? Okay, so it looks like, whatever this arch looks like, here he is, 10 feet tall. So that means that's B, because that's the value of B. It's the height from the center of an ellipse to the top. And then, what else? A width of 30 feet, but that means all the way across from the very left side to the very right side is 30. But my A value should be the distance from the center to that side. So A is half of that, 15. Because yeah, this, the A value and the B value are always from the center to the left or to the right. Or sorry, up, above and below, or left and right. So we can fill those into the equation of the ellipse, just so we kind of have an idea of what's going on with this archway. So this equation will describe the archway. The archway. Okay, so this problem should go pretty much the exact same way as the last one. We just got different numbers. This will really drive it home, though, because these problems are hard. Whoops, I put a B there, but we're not supposed to put a B because we don't know what, or we do know what B is. A was 15 and B was 10. Let's fill those guys in. A is 15 and B is 10. Okay, 15 goes here, 10 goes here. Let's see, actually, what's 15 squared? It's 225, so this is x squared over 225 plus y squared over 100 equals 1. So now, like we did in the last one, I'm going to think about the truck, or whatever I'm trying to drive through here, a truck or a car. What's the car's x value? If I were to place the car here, the truck is 8 feet wide and it has a load of 7 feet above the ground. Okay. Well, if I were to drive this truck through here, let's say he's like this. It says the width of it, it's 8 feet wide. So from here to here is 8. That means my x value is half of that, or 4. So yeah, it's because you got your x and y axes. They're telling us that, let's see, from here to here is 8. So they said this whole distance is 8, but x value should be half of that, if that makes sense. So we're going to plug in x equals 4 into this. Substitute x equals 4, and then solve for y. And you could actually do it the other way too. I didn't say that in the first one because I didn't want to confuse it, but you know, if you actually plugged in the height of the truck, which is 7, if I put 7 for y, let's see, y equals 7, and I solve for x, you know, you could still do it that way as well. That would work. But I know, I guess we're in it to win it now. I'm going to put a 4 in for x and see what happens. 4 squared, okay, let's see. 4 squared over 225 plus y squared over 100 equals 1. All right, so that's 16 over 225 plus y squared over 100 equals 1. And now, kind of like the last one, there are a few ways to solve this equation, but I think what I would like to do is multiply the whole thing by the least common denominator to clear all denominators. That'll make it easier. By the LCD, and it just so happens 225 and 100 have an LCD of 900. That's kind of a weird one. And I mean, if you didn't think of 900, you thought of a bigger number, the problem would still work. But let's see. So I'm going to go, you might want to be careful, I don't know, I feel like I'm going to make a mistake here. First, I'm just going to write 900 next to all these guys. Well, at least the fractions. On the right, I know 900 times 1 is going to be 900, but on the left, I got to really think about that. Let's see, 900 go, how does that work with this guy? And how does that work with this guy? So let's see, 9 900 goes, or sorry, 225 goes into 900 4 times. So really this and this will reduce to leave a 4 on the top. So it'll be 4 times 16, which is 64. 4, well, I could write it out just to be safe. 4 times 16, that's 64. So that's what the first term becomes. Of course, 900 and 100 reduce to leave a 9 times the y squared. So it looks like this is the equation that we're left with to solve. I'm going to move the 64 over here. Let's see. Minus 64. Minus 64. Okay, then we have 9y squared by himself. And then 900 minus 64 ends up being 836. And now I'll divide by 9. It doesn't go in evenly, but you know, we're gonna be approximating this anyway, because this is a real life situation. So I'll divide by 9. Y squared equals whatever that is, 836 divided by 9. Now I'm going to square root both sides. Whoops, let me see. Square root, okay. So I'll put that in my calculator. Y is whatever the square root of 836 divided by 9 is. 836 divided by 9. There we go. So that's about 9.64, something like that. 9.64. So that means that the archway is 9.64 feet tall, because we found the y value at how many, what did we plug in for x? It was 4. At 4 feet from the center. So I'm going to compare that height, 9.64 feet tall, with the height of the truck. How tall is that truck? Ooh, wait. Oh no, it's okay, huh? 7 feet above the ground. Okay, that's fine. I thought it was bigger. The truck is 7 feet tall. 7 feet tall. So it should fit. That is if it drives down the center, huh? Yeah, okay. Alright. Sounds good. Those are tough problems, but I think hopefully they made some sort of sense. Like I said, this chapter it's not that fun, but hey, if we get through it, then we got to feel pretty good about ourselves.